Welcome to the 14th session of galvanic cells, which comes under the topic electrochemistry, and here again it is a continuation of electrochemical energy storage devices. We have been dealing so far with the primary cells and secondary cells, and in secondary cells we have explained only lead acid batteries, and some of which we will be seeing in this session, and also some other secondary batteries like nickel cadmium battery and lithium ion battery. After that we will be dealing with electrochemical capacitors or super capacitors. Now, let us move on to the first example, that is the nickel cadmium battery. The nickel cadmium battery is a battery which is very familiar with all of us. It looks like an ordinary battery, the cylindrical ones, small ones, and these batteries, the peculiarity is that these batteries are rechargeable. So, this comes under the secondary battery, and this is a nickel cadmium batteries. Most of the cameras and all, for flashes and everything, they will be using such type of battery, that is a nickel cadmium battery. In this, it comprises of anode, which is a cadmium metal, and cathode is not pure nickel, it is nickel oxide hydroxide. That is a cathode, and electrolyte is just like in alkaline batteries, it is either mostly potassium hydroxide, in some cases it is sodium hydroxide. Okay. Now, this is the cross section of the nickel cadmium battery. It is just like a cylindrical batteries we have, and here you can see this is the outer cover case. Then we have the negative terminal, or it is the anode. Okay. It is written here, it is a anode, it is a negative terminal, and that is usually cadmium. The positive terminal, it is here, okay. It is nickel oxide hydroxide. It is not pure nickel, remember, though we call it as a nickel cadmium battery, its positive electrode or the cathode. It is not pure nickel, it is nickel oxide hydroxide, positive terminal, and in between we have a layer for separating these two, and there is a gas release vent which is self sealing type. Okay. So, nickel cadmium batteries consist of a metal case with a sealing plate equipped with self sealing safety valve. Okay. The positive and the negative electrode plates are isolated from each other by a separator. See, there is this brown colored one that acts as a separator. Okay. So, they are not in direct contact. Okay. And what happens is, we have an anode and a cathode, both separated by a separator, and they are rolled together, okay, in a spiral shape inside a case, and that forms the nickel cadmium battery. Now, let us see what are the reaction taking place within the nickel cadmium battery. The cell reactions are: anode is cadmium, we have the electrolyte KOH or NaOH, whatever it is, we will have the alkaline radical OH minus, cadmium combines with that to form cadmium hydroxide, releasing 2 electrons. Here cadmium is in the zero oxidation state, here OH minus 1, and we have 2 OH ions, therefore, that will be a minus 2, and cadmium goes to an oxidation state of plus 2. So, here this is purely an oxidation reaction. At cathode, the nickel oxide hydroxide combines with 2 electrons in the presence of water to give nickel hydroxide, releasing hydroxyl ions. One point to be noted, here hydroxyl ions are consumed during the anodic reaction, while the same number of hydroxyl ions are released during the cathodic reaction. An important point to be noted in this is, there is no consumption of electrolyte during the complete overall reaction of the cell. At anode, the hydroxyl ions are consumed, the same amount of hydroxyl ions are released during the cathodic reaction. Now, here OH has got a -1 charge, oxygen -2. So, nickel will be in the +3 oxidation state, and here we have hydroxyl ions -1, we have 2 of them. So, there is -2, and here nickel goes into the +2 oxidation state. So, nickel gets reduced from +3 to +2 oxidation state, and therefore, we can call that to be a reduction, and therefore, there is a cathodic reaction. Now, again this is a rechargeable one, and this cell reactions occur during the discharge or when we use the battery to derive electricity. During recharge or charging, what happens is these reactions are reversed. Okay. So, reversed reactions. And we have the cell ready for deriving the energy from that. Now, during recharge, reactions go from right to left, and during charging we have these to be in the opposite direction. Okay. Now, remember the lead acid batteries, what happens is the sulfuric acid is being consumed, the sulfates ions are taken up by the lead to form lead sulfate. Okay. While in this case it is not the case, the hydroxyl ions are not used up, and therefore, the specific gravity of the electrolyte does not go down. Okay, it is retained as such. So, you can expect a longer life for nickel cadmium batteries rather than the lead acid batteries, but it is bit costlier than the lead acid batteries. Okay. Now, one more point to be noted is that nickel cadmium batteries, they have long lasting capacity and also they are compact, but there is again a hazard of heavy metal poisoning. Nickel and cadmium both are heavy metals. So, the environmental hazard of heavy metal poisoning poses an important threat. Now, another drawback is that the nickel cadmium batteries, they possess a memory effect. These batteries, they have a memory effect, and what is the memory effect? Memory effect is that if a battery is discharged, that is we are using it to a particular extent and then recharged, again at same discharged point it is again recharged, and this process is repeated several times. Okay. So, the battery is under the false notion that the point from where it has been recharged, okay, that battery is not totally consumed, but we are recharging it from a particular level. Okay, the general usage is like that. So, what happens is the battery feels that once the charge is drained up to that level, battery feels that it has been totally drained, or it considers itself to be dead, though actually it has got sufficient charge retained in it. I will make it clear. That is, if we are having a battery, suppose I am using a battery, it has got 100% capacity. I am using it and my use is regular, it is the same way, and therefore, its charge drops up to some like 30% or 20%, let it be 30%. Okay. So, most of the days my usage is actually from 100% to 30%, and this is the point when it drops to 30%, I recharge it. If I continue this for several times, battery feels that once the 30% has been reached, that means battery is already dead. That is the memory effect, because battery remembers the point from where it has been recharging and considers that point to be the battery being getting dead. Okay. Now, what happens is once it is charged, suppose we need in a certain case we need more power, so that the battery charge can drop up to 10 or 20% suppose. but this battery does not go there. Once it reaches 30%, it shows that the battery is drained or it is totally dead. Okay. Now, this is known as the memory effect. Now, let us see in detail, that is, if they are discharged and recharged to the same state, that is what I am saying, that is the same state is 30%, okay, for several times. There is a symptom in that battery, that is, battery remembers the point of discharge cycle and recharging, that is, up to where it has to be discharged and from there it has to be recharged. That is what the battery remembers, and once it drops to this voltage and current density, the battery appears to be dead, that is, you cannot derive more charge from that. Okay, this effect is known as the memory effect. This is seen in nickel cadmium battery. So, what we have to do in such cases is that we have to discharge it for a longer period, so that the complete charge has been drained, and then recharge it. Once you do that, the battery can be revived from this memory effect. So, it cannot, it becomes unable to get enough energy out of that battery and battery appears dead. This is known as deep discharge cycles. Many times you allow the battery to go to the least value, that is completely drained, and then recharge it. If you do that, the battery can be revived. Okay. That is about nickel cadmium battery. It is compact, but the environmental pollution is a small drawback of nickel cadmium battery. Other one is the memory effect. Now, let us go for the lithium ion battery. This also you might be hearing of, that is, most of the laptops and all those things, they use a lithium ion battery. Lithium ion batteries has got a very big advantage, that is, it is very lightweight and has high reduction potential and low resistance, and therefore, you get a greater charge density and potential from these lithium ion batteries. And lithium ion batteries, they do not contain pure lithium, and therefore, it is more safe for charge and recharging. Okay. Now, this is a picture, this is a schematic diagram. We have an anode, usually a lithium carbon compounds are used as anode, and we have a cathode, usually that is a lithium along with metal oxides. Okay. This is, they have shown lithium cobalt oxide, and this is anode is not purely graphite, it is lithium carbon compound. Okay. Now, we have an electrolyte, I will mention the electrolyte later. Now, what happens is that here the lithium ions will be produced, and these lithium ions go to the cathode and they get inside this cathodic material. Okay. This is when the cell is getting discharged, that is, when we are deriving electric current, lithium ions move from anode to cathode and they get incorporated in the cathodic material. Now, what happens during recharging? What happens is these lithium ions come back to this anode. Okay. Or you can say that there is a movement of lithium ions from anode to cathode, and also during recharging we have the movement from cathode to anode, lithium moves like that. Okay. Now, let us go in detail. The anode is lithium carbon compounds, lithium carbide, and here we have cathode as lithium metal oxide, usually it is lithium cobalt oxide. Now, lithium, I told you the lithium ions will be formed at the anodic reaction, and this lithium ion is highly reactive if it gets contact with water molecules. It really explosively reacts with water and releases hydrogen, and therefore, the electrolytes can never be in the aqueous condition. Here we have organic compounds or solvents, and the electrolyte is lithium hexafluorophosphate dissolved in a mixture of organic carbonates such as ethylene carbonate or propylene carbonate. Got it? It is very important. You cannot use an aqueous solution. Lithium hexafluorophosphate dissolved in either ethylene carbonate or propylene carbonate or mixture of that. So, that is what we use it, organic compounds. The reason is that lithium ions are highly reactive with water to form lithium hydroxide and oxygen. So, always we have to, you should remember, we should use only non-aqueous electrolytes, and the battery should be completely sealed in order to prevent the enter of moisture inside the battery. That is the point to be noted. Okay. Now, let us see what are the cell reactions. At anode, the lithium carbon compound gets converted into carbon and lithium ions with the release of 2 electrons. Okay. At cathode, cobalt oxide combines with lithium ions and 2 electrons to form lithium cobalt oxide. Here reduction occurs and here we have the oxidation. Lithium carbide goes as lithium ion. So, that is again an oxidation. In this, lithium ion gets reduced and gets converted into lithium cobalt oxide. So, at one point we are having the oxidation of lithium, the other case there is a reduction of lithium. Now, both the electrodes, the peculiarities allow lithium ions to move in and out of their structures with a process called insertion. Actually, they are lithium, there is a graphite in which we have the lithium, and these lithium they move out as lithium ions and reaches the cathode where the lithium ions are inserted into the cathode. Now, this process is known as intercalation. Okay. Intercalation. Now, here or extraction, that is lithium is being extracted out, that is we are having a graphite in which we have lithium and from that lithium is being extracted. This is known as de-intercalation. So, these are the process taking place, de-intercalation from where lithium ions are extracted and then they are introduced into, inserted into the cathode, we call that to be intercalation. Okay, these are the process. Now, in this process actually what is happening is that lithium ions rock back and forth between the 2 electrodes, is not it? Lithium ions coming from anode going into cathode, right. Now, when I am going to recharge, the opposite reaction will take place. So, the lithium ions rock back and forth between the 2 electrodes and these batteries are also known as rocking chair batteries or swing batteries. They are also known as rocking chair, moving to and fro. Okay. So, it is known as rocking chair batteries or swing batteries. Next, we will see electrochemical capacitors or supercapacitors. Now, capacitors in which we are using superconducting metals and as a dielectric, if I use an electrolyte, we call that to be an electrolytic capacitor. Okay. They have activated carbon between the electrodes. When an electric field is applied to the material, an electric current double layer, electric double layer is formed at the supercapacitor and the dielectric. That is, you are having the supercapacitor, that is metal coated with activated carbon, and we have an electrolyte, and at this surface we have an electrical double layer formed when we pass the current. It is not any chemical reaction. Just remember that in this type we do not have any chemical reaction. What is it? We are giving current, polarizing it, you make the positive pole and the negative pole and their electrical double layers, which we will be seeing in detail. Okay. This electrical double layers act as a charge storages, and whenever it's charged and remains like that, and after that when we need the charge, you can tap it from that. So, this is a static electrostatic charges stored. Okay. So, it is a static energy, electric energy stored in that. Okay. We will see in detail. The electrical double layer capacitors have 2 electrodes. Okay. They are mechanically separated by a separator and ionically connected through an aqueous electrolyte. Okay. Each of the 2 electrode surfaces originates an area in which the liquid electrolyte is in contact with a conducting metal surface. At this interface occurs a very special phenomenon of double layer. Okay. And this double layer, how does it works on? The charge storage mechanism is the physically stored surface of the electrodes without any irreversible chemical reaction taking place. There is no chemical reaction, it is only the storage, that is, it is getting electrical double layer. It is not due to chemical reaction, but just by the formation of polarization, that is, they are getting charge separations. Okay. And this is stored in the form of an electrical double layer, and whenever required you can tap this charge as an electric current. So, these type of super capacitors are also known as electrical double layer capacitors or EDLC in the short form, electrical double layer capacitor. Now, I will show you the mechanism. See, actually what happens is we have a positive terminal and a negative terminal. Okay. See, here it is the positive terminal, and then when we give a electric current, what happens is the positive terminal or the positive electrode, this is the positively polarized electrode, what happens is it attracts the negative ions towards it, right. More of negative ions towards it. Of course, there will be positive ones, these are the blue colored, they are there, but to a smaller extent. More of negative ions will be attracted towards itself. While in where we have given a negative polarity, what happens is that will be negatively charged, and that attracts the positively charged towards itself. Okay. And we have an electrical double layer, that is a positive electrode in contact with the negative ions, it forms an electrical double layer. On the other side, we have the negatively charged electrode with more of positive ions near it, and there forms an electrical double layer, and whenever required you can tap this energy, and this is how energy is stored in a supercapacitor or electrical double layer capacitor. There is no any chemical reactions, only the polarization and attraction of opposite charges causes the formation of the electrical double layer. Okay. Now, there is another type of capacitors known as pseudo capacitors. So far, you have been dealing with the capacitors in which there is no electrochemical reaction taking place and charges are formed just due to the polarization effect. Now, here in pseudo capacitors, what happens is that here there will be a redox reaction taking place at the electrode surface. Okay. And due to that there will be an electrical double layer created. Such are known as pseudo capacitors. They are not true capacitors because there is an electrochemical reaction taking place, and as a result it forms an electrical double layer. It is not simply due to polarization. The pseudo capacitor has a chemical reaction near the electrode or at the electrode surface, where the charges are transferred across the metal and electrolyte interface, thus forms the electrical double layer and the charge is stored. So, if it is so, we do not call them to be an capacitor, we call that to be a pseudo capacitor. Okay. Now, we have the another class of capacitors known as hybrid capacitor. So, in pseudo capacitor, we have a chemical reaction, that is a redox reaction taking place, and as a result we have the electrical double layer. In the case of hybrid capacitors, hybrid itself means that there are two varieties of capacitors combined together. Okay. These capacitors have both mechanism of electrical double layer capacitor and pseudo capacitors combined. So, there is two capacitors, they are combined together. In hybrid capacitors, what happens is one of the electrode will be functioning in one way and the other electrode will be in the other way. That is, one electrode will be exhibits electrostatic capacitance, that is by polarization, while the other electrode will be electrochemical capacitance. So, these two electrodes, they have electrical double layer, but by two mechanisms. One is the true capacitor mechanism, other one is the pseudo capacitor mechanism. Pseudo capacitor mechanism where there is a electrochemical reaction taking place, and here just polarization and the double layer is created. Now, what happens is anyway the double layer is created, the energy is stored and you can tap this energy whenever it is required. And one more important advantage is that such type of capacitors, they have higher operating voltage and increased capacitance, capacitance is very high and a very large energy density. So, these are better than either the ordinary capacitors or super capacitors and also pseudo capacitors, hybrid capacitors, and this is a recently developed topic and this is the researchers are going on. They are going to planning to replace batteries by capacitors, which will be thought to be more cheaper and easy to handle. Okay. Now, let us conclude the session. In the session, we have been seeing the secondary batteries, which is a continuation, the lead acid battery we have seen in the last session, and in this session we have been seeing nickel cadmium battery is again rechargeable one. Then the other one is lithium ion battery. Then electrochemical capacitors and supercapacitors, we have been seeing electrical double layer capacitors, pseudo capacitors and hybrid capacitors. Hybrid capacitors are those which include both these techniques together, they are hybrid, forms the hybrid capacitor. Thank you.